Welcome back. Here is a solution to your homework. Record your answers, make any corrections that need to be made. You won't be turning it in today, you'll be turning it in tomorrow. Yesterday we went ahead and used long division to divide our polynomials, even factor some of those polynomials, those where the remainder was equal to 0. Instead of doing long division, sometimes in special cases we can use synthetic division. So remember about synthetic division. So this form here, but it only works with polynomials when we have a divisor of x minus k. The way that synthetic division works is you start off by writing with your divisor of x minus k, just writing down the k. Then over here, we go ahead and write down the coefficients of our variables. In this case, for ax cubed plus bx squared plus cx plus d, our coefficients are a, b, c, and d. Don't forget, if you do have a missing variable, you want to put in that 0 coefficient for the placeholder. And then all we have to do is you're going to be adding, when you're doing vertical, going down, and the diagonals, you're just going to be multiplying by that k. So for instance, in this particular example, going straight down, the very first thing you're going to just drop down that a, whatever that coefficient was. Going up to the next, we're just multiplying whatever we have at the bottom by k. Now we're just going to be adding, in this case, b plus ka, whatever that answer is, multiply by k, and keep repeating this process. And then the first part, as it says here, will be your coefficients of your new quotient, and your remainder will be that last term. So what does this look like? Well, here we want to use synthetic division to divide 5x cubed plus 8x squared minus x plus 6, all divided by x plus 2. So we can use synthetic division since it is in the form x minus k. At minus k, again, my x plus 2 is just x minus a negative 2. So I have my k, and then we go ahead and just write down the coefficients: 5, positive 8, negative 1, positive 6. And now the vertical, again, that very first term, we just drop on down, which is a 5. And over here for the diagonal, 5 times my k. So 5 times that negative 2 be a negative 10. And now we're just adding. 8 minus 10 gives me that negative 2. Diagonal again, negative 2 times negative 2 gives us a positive 4. Negative 1 plus 4 giving me a 3. Diagonal, 3 times negative 2 gives me that negative 6, ending up with a remainder of 0. So this particular quotient that we have left over here, this 5 represents my 5x squared minus 2x plus 3. So when we have our division of 5x cubed plus 8x squared minus 8x plus 6, dividing by x plus 2, we wind up with a quotient 5x squared minus 2x plus 3. And this next one, x to the 4th minus 10x squared minus 2x plus 4, divided by x plus 3. Again, my divisor, minus 3. And then my coefficients for x to the 4th, I have a 1. And then you notice that we are missing the x cubed, so we're going to put in that 0 placeholder. And then for x squared, negative 10, negative 2, and then a positive 4. So now we again drop down that coefficient of 1, multiply, 1 times that negative 3, add straight down. Diagonal, I want to again multiply by that negative 3, giving a positive 9. Negative 10 plus 9 gives me that negative 1. Negative 1 times negative 3, positive 3. Adding, we get a positive 1. And our last multiplication, 1 times negative 3 gives me that negative 3. And when we add, we find out that we get a positive 1 for the remainder. So here, we wind up with these being the coefficients of my quotient, which would be x cubed minus 3x squared minus x plus 1. And I had that remainder plus 1 dividing by my quotient, excuse me, my divisor of x plus 3. So this is what we get when we divide x to the fourth minus 10x squared minus 2x plus 4 divided by x plus 3. Definitely takes up a lot less space than if you're doing long division. So for this example, 3x cubed minus 17x squared plus 15x minus 25, all divided by x minus 5. My divisor, and then the quotients, excuse me, the coefficients, 3, negative 17, 15, negative 25. Repeat the process. 3 drops down. 3 times 5, 15. Gives us a negative 2. 5 times negative 2, negative 10. 15 minus 10 gives me that positive 5. And then lastly, 5 times 5, giving us 25. The remainder of 0. Winding up with a quotient of just 3x squared minus 2x plus 5. And then the last one, we have our x cubed plus 512 divided by x plus 8. A few missing coefficients here, a few missing exponents. So dividing by that x plus 8, again, we have our divisor of minus 8. My coefficient for x cubed is 1, but for x squared and x, I need to put in those 0 coefficients. And lastly, 512. Dropping down that first coefficient, and then doing our multiplying and adding, giving us a negative 8. 0 minus 8. Negative 8 times negative 8 gives us 64. Dropping that on down, and then 64 times 8 gives us, negative 8 gives us a negative 512, remainder of 0. So then x cubed plus 512 divided by x plus 8 gives us a quotient x squared minus 8x plus 64. Definitely time saver doing synthetic division versus long division, especially when we have that x minus k as a divisor. The remainder theorem. So if a polynomial f of x is divided by x minus k, the remainder, which is just our r, is equal to f of k. So if I try to evaluate a function for k, it's the same thing as if I just divide by x minus k. In other words, here we want to use the remainder theorem to evaluate, in this case, f of negative 1, where f of x is given by 4x cubed plus 10x squared minus 3x minus 8. So here, my k, negative 1, and my coefficients 4, 10, negative 3, and negative 8. Using our synthetic division, again, the 4 drops down, negative 1 times 4, adding, we get to 6, multiplying back to negative 6, negative 9, we have a positive 9 with that negative 9 times negative 1, giving us a remainder of a positive 1. So from the remainder theorem, we know then that f of negative 1 is equal to 1. In this particular case, we could have also just evaluated, sticking negative 1 for our x. May have actually been a lot simpler. However, if we look at this problem, f of x equals x to the 5th minus 13x to the 4th minus 120x plus 80. Evaluating that for a negative 3, especially taking that to the 5th, to the 4th, and multiplying with those large numbers. In this case, synthetic division works out a little bit better. So here, dividing, again, negative 3, and then my coefficients, 1, negative 13, and then we have some missing coefficients, some zero coefficients which we need for those missing terms, for the third and for the second. And then we have a negative 120x and a positive 80. So once again, dropping down that first coefficient, that leading coefficient. And now we multiply that leading coefficient of 1 by our divisor negative 3. Adding gives us that negative 16. And again, we just keep repeating this process. Negative 16 times negative 3, 48. 48 times that negative 3, negative 144. And then 144 times that 3 gives us 432. Negative 120 minus 432 gives us 312. And finally we get that negative 936. Adding with 80, we get a remainder, negative 856, telling us that f of negative 3 is equal to negative 856. There are a few large numbers in here. However, using a negative 3 into the formula, into our original equation, we'd have a negative 3 raised to the 5th minus 13 times a negative 3 raised to the 4th minus 120 times a negative 3. A little bit more cumbersome than just coming up with a remainder here of negative 856. This is one useful tool of using our synthetic division. The factor theorem. A polynomial f of x is said to have a factor of x minus k if and only if f of k equals 0. It's the same thing we talked about with the long division. If we wind up with a remainder of 0, that very last position, then we know that we actually have a factor, the x minus k, the one that we're dividing by. So for instance, here we want to show that x plus 3 is a factor of x cubed minus 19x minus 30, and then find the remaining factors. So, my x minus k, in this case that k would be a negative 3, and then my coefficients of my dividend, we have 1 for our x cubed, nothing for our x squared, so we put in that 0 placeholder, negative 19 for x, and then a negative 30. So if this is going to be a factor, we should have a remainder of 0. Let's find out. So dropping down that leading coefficient, and then multiplying by negative 3, adding, again multiplying by negative 3, giving us a negative 10, and finally we do wind up with that 0. And this 1, negative 3, and negative 10 represents the coefficient of our quotient, x squared minus 3x minus 10, which is just a simple factor of x minus 5 times x plus 2. So here we can see that what we started off with, x cubed minus 19x minus 30. Originally we had that x plus 3 as a factor, which then gave us x squared minus 3x minus 10, which we later determined was just x minus 5 times x plus 2. So here, by using the division, knowing the factor, that first factor of x plus 3, we're able to get our quotient of just a polynomial of degree 2, a quadratic, which we're able to factor into that x minus 5 and x plus 2. So division, whether it's synthetic or long division, does help us out quite a bit in factoring a polynomial. Here we want to show that x minus 2 and x plus 3 are factors of f of x. You can 2x to the 4th plus 7x cubed minus 4x squared minus 27x minus 18. So starting off with either one, starting off, let's say, with the x minus 2, so we have 2, and then our quotient of 2x to the fourth, 7x cubed, minus 4x squared, minus 27x, minus 18. Drop down that leading coefficient, and 2 times 2 is 4, giving us an 11, negative 22, excuse me, positive 22, and subtracting, giving us an 18. 18 times 2 gives us a 36. Adding, we get the 9. And then one more multiplication. We find out we have that 0 remainder. So what we have here is we took that f of x, of that 2x to the fourth plus 7x cubed minus 4x squared minus 27x minus 18. We now know that x minus 2 factor, when we divide it, we round up with this quotient of 2x cubed minus 11x squared, excuse me, plus 11x squared plus 18x plus 9. So we did take it down one more power. We also know x plus 3 is a factor of our f of x, which means it's also a factor of this. So now we just going to use our x plus 3 and divide it into our quotient, which we attained there. So we're going to have our negative 3, and then our 2x cubed plus 11x squared plus 18x plus 9. Dropping down the leading coefficient, 3 times negative 3, negative 6, giving us a 5, times negative 3, negative 15. Adding, we get the 3. 3 times negative 3, negative 9, ending up with a remainder of 0. So now we have our f of x equal to that first factor of x minus 2. And now this, we already know that we just divided by the x plus 3, and it gave us a quotient here of 2x squared plus 5x plus 3. And then we look at our 2x squared plus 5x plus 3. It just breaks down to 2x plus 1 I'll lay my last on that for the 2x squared plus 5x plus 3. That breaks down to 2x plus 3 and x plus 1. As far as our 3x plus 2x giving us. So here we've taken the f of x, completely factored it by using our synthetic division, knowing the two zeros, or the two factors, x minus 2 and x plus 3. And just using synthetic division twice, we were able to find out all the factors, x minus 2, x plus 3, times 2x plus 3 times x plus 1. So this is a very useful tool in coming up with our factors. Again, breaking on down as far as using the remainder in synthetic division. Our remainder r gives us the value of f at x equals k. Again, where our remainder is just f of k. Using our synthetic division, we know what that value is. Or if our remainder is equal to 0, we also know that x minus k is a factor of f of x. And also, if we have that remainder of 0, we also know that k0 is a x-intercept of the graph of f. Again, this is why we use synthetic division. It is a helpful tool, and it also helps out in your homework, which is right here. enjoy. I will see you all on Monday.